Hi everyone, my name is Daniela and today we're going to travel back in time to see how ancient people built massive monuments that line up perfectly with the sun, moon, and stars. This field is called Archaeoastronomy. So archaeoastronomy is the study of how ancient civilizations built structures aligned with the sky and celestial events. It's super cool because it once again shows that these ancient people were advanced scientists and builders, proving the capabilities of the human mind. Let's start in England about 4,500 years ago. Stonehenge isn't just a random circle of rocks, it lines up with solstices. On the summer solstice, the sun rises directly over the heel stone. This let people track the longest and shortest days of the year. Now we jump to Peru, where the ancient people built Chanquillo, a solar observatory with 13 towers. Throughout the year, the sun rises and sets at different points along the horizon. By watching which tower the sun aligned with from the observation point, people could figure out the exact time of year. Another cool thing to know about is something called the zenith sun. That's when the sun is directly overhead at 90 degrees. It only happens if you live in the tropics, between the Tropic of Cancer and the Tropic of Capricorn, so not here in Canada or Europe. On those days, shadows basically disappear because they're cast straight down. The anti-zenith sun is when the sun is exactly on the other side of the earth, directly under your feet. However, you can't see it because it's nighttime when it happens, but it's still part of the same cycle. Here's an example of the September equinox sunset being viewed through the towers. Meanwhile, in Egypt, the pyramids of Giza are another speculated example of archaeoastronomy. Some researchers believe they are aligned with Orion's belt. As you can see in these diagrams, for the ancient Egyptians, Orion was linked to Osiris, the god of the afterlife. So by building the pyramids in this pattern, they were literally connecting their pharaohs to the heavens. Inside the Great Pyramid, some of the shafts are even pointed toward Orion's belt and other stars, almost like a cosmic exit route for the pharaoh's soul. Across the world, we see the same fascination with tracking the sky in completely different cultures. However, one of the most incredible examples comes from the Maya at Chichen Itza. On the spring and fall equinox, the pyramid called El Castillo creates an incredible visual effect. As the sun sets, the sunlight hits the northwest corner of the pyramid staircase, and a series of triangular shadows form along the steps. From a distance, these shadows line up perfectly with the edges of the staircase to look like a giant serpent crawling down the side of the pyramid. The serpent's head seems to meet a carved stone serpent at the base, completing the effect. The pyramid itself also has 91 steps on each of its 4 sides, plus 1 at the top platform, which adds up to 365 steps, the number of days in a year. This pyramid is a representation of the 4 seasons with its 4 sides and the days in a year. This is yet another incredible example of ancient civilizations building insanely advanced forms of solar calendars into their structures itself. As we've seen in class, the equinox is when the tilt of the Earth's axis is perpendicular to the sun, which makes day and night roughly equal everywhere on Earth. This happens because Earth's 23.5 degree axial tilt and its orbit around the sun cause the sun to cross the celestial equator. At this time, the sun rises and sets in predictable spots along the horizon, and its declination is 0 degrees. The Maya didn't have telescopes, but they tracked these changes carefully over years using the horizon, shadows, and careful observations of the sun's path. The alignment wasn't just for show, it had practical and cultural uses. It affected their agriculture through being able to time planting and harvesting to the sun's path. The structure also served ceremonial purposes honoring their sun gods in rare events like eclipses or planetary alignments, which were sometimes seen as omens. And of course, keeping track of celestial events let them measure the passage of time and create accurate calendars. This wasn't unique to the Maya. If you compare it to Stonehenge, the summer solstice and sunrise alignment served similar cultural and practical purposes. It's amazing to see how these completely separate civilizations figured out the same solar patterns. Today, archaeologists use astronomy software and simulations to confirm these alignments. Programs can recreate the sky as it would have looked thousands of years ago, accounting for changes in Earth's tilt, precession, and even the drift of stars over time. One program we've looked at in class is Stellarium, which lets you jump back in time and see exactly how the stars lined up. It allows you to go backwards and forwards about 10,000 years. But if you dig into the settings and install extra plugins, you can actually push it much further. Researchers also use satellite imagery, laser scannings of the sky, and GIS mapping, helping them measure the orientation of monuments with extreme precision. There are still challenges though, like erosion or reconstruction, and interpreting cultural intent make it tricky to be 100% sure. But with careful methods and modern tools, researchers can separate guesswork from real patterns. A really cool modern connection to the art scene is James Turrell's Roden crater. Turrell has been transforming an extinct volcano into an observatory and art installation since the 1970s. Just like these ancient civilizations, his designs let people experience celestial events in a unique and immersive way. Visitors can watch the sun rise or set through carefully aligned apertures on solstices and equinoxes. They can see the moon pass across the sky and even observe certain star risings and planetary movements framed perfectly by the crater's openings. Here's a topography map of Roden crater. So I actually looked at Roden crater in another class, and it made me realize how humans today are still so fascinated by building structures that connect directly to the sky, creating a physical and visual representation of astronomy. Here's an example of a 2012 winter solstice event. So why is the study of astronomy relevant? It shows us that ancient people weren't just building cool monuments, they were advancing science and our understanding of the stars through careful observations and calculations. From Stonehenge to Chichen Itza, cultures across the world left us these amazing markers of their knowledge, creativity, and connection to the stars. Even today, projects like Roden crater remind us that humans continue to be fascinated by the sky and our place in the universe. It really makes me wonder what kinds of things we will be capable of building in the future as technology and our understanding of astronomy and architecture advances. Thanks for listening, and I hope you all learned something new and interesting with this video.